Thank you everyone for coming out and braving the torrential rainstorm to see all these demos the team worked on and come see us talk. So I'm Evan Schwartz. I'm one of the engineers that works on the Codius project, and this is
Stefan Thomas. I'm CTO of Ripple Labs.
All right, so tonight we're going to be talking about Codius, where smart programs live. So in this talk, we're going to be going through cryptocurrencies and the idea of smart contracts. We're also going to be explaining Codius, the ecosystem for smart programs, and we're going to talk a little bit about the future of autonomous applications. So let's get started with cryptocurrencies and smart contracts.
So how many of you have heard of smart contracts before? Wow, that's quite a few. And how many of you understand what smart contracts are? That's a lot less.
All right. So let's start with something that we know and understand pretty well, not like smart contracts, but rather credit cards. How many people have a credit card in their wallet right now? All right. So that's a lot more. So credit cards are great because they're accepted everywhere. They're very easy to use. That you can do things like subscriptions with them, and they're just damn convenient. The cons,
they sometimes get compromised, and sometimes at large scale. So whenever there's a database that's holding tens of millions of cards, there's a single point of failure that people can break into. And that happened with Target, it happened with Home Depot, it happened with Chase. And it just seems like the numbers keep growing and growing every single time.
And the main problem here is that every time you use a credit card, you're basically handing someone else the keys to all of your money, which is pretty not ideal.
No.
So cryptocurrencies are a lot more secure.
And that's because every single transaction is signed with a cryptographic signature. And that's just built into the very core of the protocol. So there's no way around it. Unless you can break the fundamental mathematics, you just cannot forge a cryptocurrency transaction. Right,
and so unlike with credit cards, where you hand over the keys to all of your money every time, with a cryptocurrency payment, instead, you're just making one payment, and it's just that one, so there's no way to forge it. So cryptocurrencies are faster, cheaper, and better.
Yeah, so you all saw the demo about Saldo MX up there. The way it works there is that if you have someone in the US and they want to make a remittance bill payment into Mexico, they can just go open up the app, go to an agent, deposit the money, and send it over, which is really convenient. That's really good. And that's the kind of thing that cryptocurrencies enable, right? Really small entrepreneurs that are building cool stuff. They can directly interact with the protocol. There's no limitations. And that's really a huge change from the financial industry where there's very little API access and it's very hard for a small guy to get started.
So at Ripple Labs, what we're interested in is building what we call the value web. We're trying to make it so you can move value of any type anywhere in the world as easily and quickly as you move information today.
That sounds really good, Evan. Tell me more.
So this is great, but the problem with the picture that we painted before is that every time you want to make a payment through Saldo MX, you have to go back to an agent and make the payment.
Couldn't you just have a subscription of some kind?
Yeah, so ideally you would just have a subscription. The problem is that, as we said before, every single transaction has to be signed. And so this is great for security, but not so great for doing if we want to do things like subscription payments.
So really what you want is a cryptocurrency wallet which has a brain, so that it can sign transactions on your behalf, but only in the way that you want it to.
Yeah, and so ideally what you would have is you would have a wallet that actually has some kind of logic built into it. So what we really want for these subscription cases is I want my money held in some kind of intelligent wallet so that I can give you a little token that gives you access to, say, $10 per month. Or if it's Saldo MX, maybe I want to set it up so that it's $50 per month. But the wallet is intelligent enough such that if some random person comes and says, please give me access to all of the money, the wallet would say, who are you? And would send you an apology instead of actually sending you the money. And similarly, if Saldo MX or whoever got hacked, then suddenly came and instead of asking for their normal $50 per month, they were asking for $50,000, the wallet would say, no, you only have access to $50.
So that's really nice. Now we have a subscription wallet. We can send money in November, and then in December it can go automatically, just without you worrying about it. So that's cool. Smart contracts in general add functionality to cryptocurrency networks, and that's why people are very excited about them.
Now, another example that people talk about a lot is escrow. How many people in the audience know what escrow means? So escrow is basically letting someone else hold on to your money until some conditions are met. So let's take a simple example of I want to buy some event tickets on Craigslist. And now the problem for me is that I don't want to send the money without the person sending the tickets, and they don't want to send the tickets until they've gotten the money. So we're in a kind of catch-22. So what we could do is we could pay an escrow service to hold on to it, and they would only release the money when the tickets were actually transferred. Now, the problem with this kind of service is that it's very expensive. And so especially for a small kind of use, like the one I'm showing here, it's really not worth using an escrow service. So instead what we could do is imagine a smart contract or a little program that we can entrust with the money, and the program can check when the tickets have actually been sent, and then we'll transfer the money. It's a lot cheaper, a lot more automatic. So in general, smart contracts make contracts like this escrow example cheaper, faster, and more automatic.
But smart contracts are just the beginning, because if you have a contract like this, it only has one function, right? So we talked about subscriptions before. We have this kind of subscription wallet. It has these very simple rules, and you have to put money into it in order to make it work.
Yeah. So every time you want to use you want to do some kind of subscription, you have to fund the account that's holding on to that. The problem is, what happens if I want to do a subscription payment and an escrow payment? I don't want to have to deal with my money being split up and tied up in each of these cases.
So that's what I was going to say. You know, a subscription wallet is just a one-trick pony. It's like you tie your money up with one particular contract. It's a one-off thing, and it's not as useful as if you had something that is a bit more modular.
Yeah, so modularity is better. Modularity meaning we can combine different pieces of functionality. So ideally what I would have is just one wallet where I can plug in different bits of functionality when I need them. Like I can have subscription payments, I can have pull payments where I might swipe a card and a merchant would pull money out of my account. I could do something like an authorization hold where I go to a hotel and, you know, just in case I spend money, they put a hold on $200 and then they haven't actually charged me, but they're just holding on to it. Similarly, I might want something like password recovery or spending limits so that if my account gets compromised, the attacker can't just clean it out in one go.
So a modular wallet has almost too much functionality to really call it a smart contract anymore. Because again, contracts are things that are one-off. You kind of sign it. It might exist for a while, but it's not designed to be modular, and it's not usually something that you extend and kind of keep developing.
Yeah, so this kind of contract, or this kind of functionality, we call a smart program.
Codius is an ecosystem for these things. So rather than, we are trying to build a hosting platform, a system where you can write software that is modular, distributed, and secure. And we try to make it as easy as possible for the developer who's used to more traditional technologies.
So how does Codius work? Let's take a look at it. So if we look at standard software architecture, it's normally laid out in 3 tiers. So at the top level, you have your user interface. That's basically the website or the mobile app that you interact with. Behind that, there's some kind of application logic layer, and that's like the meat of the service. And then behind that, you have the database, and that's where you keep all the information, etc.
In the distributed world, you also have a front-end layer where you have clients, people are developing all sorts of wallets for Bitcoin and Ripple, and you have a database layer because Ripple and Bitcoin are themselves pretty much databases. They store information, they store data, they provide some of the traditional guarantees that databases provide of durability, consistency. If you're a computer scientist, you know these terms. But the thing that's really missing is this middle layer where you can have your application logic, and which is tying all the different clients to all the different databases. So what up with that?
Yeah, so that's where Codius and smart programs fit in. We see it as that missing application logic layer for the distributed web.
So one nice thing about that architecture is that now that you have the smart programs divorced from the underlying database, they can now talk to any database. So you can have one smart program that is actually a bridge between Bitcoin and Ripple, or Bitcoin and Ethereum, or any kind of ledger that you want to use. And so that just makes it a lot more flexible, and it's also much closer to the way that developers think about programming today with this 3-tier architecture.
Yeah, and so in addition with Codius, you can host your program on one single server, or on multiple. Now, the advantages of hosting it on multiple is obviously security. So if one of the servers gets hacked or compromised or just goes down, then your program is still operating fine. So in general, more redundancy is more security.
And you can take that to the extreme. You can have thousands of servers running your software, and you can call it trustless. But there is one issue with it, because as you add servers, the cost goes up. And so it's always a trade-off. If you have too many servers running your code, then every single transaction is going to cost you 10,000 times what it would cost to run on one server. And a lot of people are already concerned with the hosting costs with things like Amazon. So you have to kind of make that trade-off based on your use case. If you have a use case where there's high risk, and there's high values involved, then you might want to run on more servers. If you have a use case which is lower risk, but you need it to be really, really cheap, then maybe you just run it on one or maybe a handful of servers.
And the nice thing about the Codius platform is that it lets the developer choose based on the use case. And the real problem that we're trying to address here is that there's no standardized cloud hosting platform today. So right now, there's lots of ways that I can write a program and have Amazon run it even on 10,000 different machines, but they're still all controlled by Amazon. And so if Amazon gets hacked, I haven't really built that much more fault tolerance into my system. Ideally, what I would have is I want Amazon to run one instance. I want Google to run another. I want play that out however long you want. But the problem is that there's no standardized way to do this today. And so if I wanted to do this, I would have to set up individual accounts with all of these services, and it's basically infeasible. So Codius is that kind of standardized way to do it.
But there's a second issue here. So we already talked about the trustworthiness from redundancy, but you still are worried about what code is actually running. So right now, if you go to something like Facebook, you don't know what code they're actually running, if they're sending any information to the NSA or whatnot. So it would be really nice to have programs that have built-in transparency in terms of what code is actually running. And we kind of mentioned that you might be uploading it to different hosts. If you did this today, one of the problems you would run into is that whoever uploaded the code, you'd have to trust them that they actually uploaded what they said they uploaded, because they're the administrators of the server. They can do whatever they want. Codius is designed such that the host can tell you what code it's currently running, so that even if someone else that you don't trust uploaded the code, you can still be confident that it's the code that you're looking at and that you have reviewed.
Yeah, and so we call these open source services. And so if there's some code running on a server, you can actually inspect exactly what bit of logic is running. And so in that way, you can gain more trust in exactly what you're interacting.
Another thing that's really important to us here at Ripple Labs is web technologies. We believe in the web platform. We believe in the enthusiasm and the things that is provided for us. And so everything we build, we try to build it in sort of a web-compatible way. With Codius, for example, that means that the default programming language for this platform, the one that we do all of our examples in and so on, is JavaScript. JavaScript is kind of the language of the web. It's used in web pages. It's been designed from the ground up to be sandboxed, not have access to unlimited resources. And so it was a really good fit for this kind of smart contract model.
So another piece of this integrated with web technologies is that Codius smart programs can actually use standard web protocols to talk to one another. So all the different instances of my program can communicate using HTTPS. And because they can access HTTPS, they can actually talk to any type of APIs. Normal data APIs, something like Twilio, which is a SMS API. These smart programs can actually talk to all of these standard APIs that developers are used to working with.
So finally, let's look at what kind of future these kinds of technologies enable. First of all, when we talk about autonomous applications, how do you picture that? How do you imagine that? An autonomous application is basically an application which is no longer dependent on its developer. So it would keep running if the developer went away, stopped caring, stopped paying for hosting and whatnot. It's just a program that's running on its own. And you can imagine that in a number of different ways. Like, are these going to be kind of the nice, friendly autonomous programs or the not so friendly ones? And so we want to make an argument that actually we think that the problem right now is that there's just not a good place for legitimate autonomous programs to live. Right now, the only way that a program can survive and replicate is by breaking into systems, being all malicious and evil, and just exploiting things. And that's the only way that it can actually replicate. But if you had a platform like Codius where any program that has the money to pay for it can just buy a host, maybe some of these programs would be actually pretty beneficial and be things that are trying to earn money in order to replicate.
Yeah, and so with Codius and cryptocurrencies, smart programs can actually hold money and pay for their own existence, basically. And so if you set up a service that was useful enough for people to pay for, it could maintain itself indefinitely.
So that's really the part that's absolutely crazy, because previously that was unimaginable. You know, you couldn't have a program going to a bank trying to get a bank account. It just doesn't work. But with cryptocurrencies and some of these new smart program technologies, you suddenly can do this.
Yeah, and so smart programs could even do things like pay developers to maintain them. This is an idea that's been talked about by a number of other people. And so you could imagine this program that's that's making money as a service and paying for its own hosting. It could even pay developers to make better versions of itself, which is a kind of crazy thought.
So one of the things about smart programs that we really think is really interesting is that you can fork them and you can change them, right? So just in the same way that people are in the Node.js community taking modules and making these very small reusable modules, that's kind of the same kind of infrastructure ecosystem that we envision for Codius. And the reason for that is there's a lot of sort of modular functionality you could imagine people developing that's useful for all kinds of programs. So make that shareable, make that a common good that everyone contributes to, and make it very easy for people to contribute to that shared resource, which is very, very powerful.
And just for all the non-developers in the audience, what forking means is if someone has their code as an open source module, I can actually go and look at it, make a copy of it, and then make improvements. And in that way, you can see these smart programs constantly being improved by different sets of people.
Yeah.
And so if we go back to that original example that we had, we were talking about the modular self-sustaining wallet. Now, we imagine that I might want some functionality out of this, but you might want a different bit of functionality. So we can envision many different versions of this existing in the wild. And one of the nice parts about this kind of ecosystem is that they can actually exchange components. And one can use, you developed a component that I really like, great, I'm going to take that, and vice versa. So that's a really excellent way of thinking about this kind of ecosystem.
So one of the things that we want to enable here, and that's again like coming from the perspective of Ripple Labs, one thing that we care a lot about is bridging Ripple with other networks and other ledgers out there. So for example, in the case of some of these cryptocurrencies, we want to have trustless bridges between Ripple and these cryptocurrencies so we can process transactions between the two. And the same goes for other ledgers that are outside of the cryptocurrency world. Like all of the existing centralized ledgers, we want to talk to those too. And so Codius, by having this architecture where contracts, smart programs don't have to be deterministic, so they can talk to any kind of API, and they support HTTPS and so on. They can talk to these things, but they can also talk to these things over here. So we have full flexibility to build smart programs and interconnect some of these things that are happening in the space.
Yeah, so speaking of smart programs interconnecting things, you could imagine tons of possibilities. One that we like talking about is imagine an open source Spotify, where rather than it just being one company that controls access to all of these different kinds of music, you could have an open marketplace where people are interacting with it and paying the artist directly. And because if it's open source, people can develop better versions of it constantly.
In principle, you can imagine any service that's out there and have an autonomous version of that. So for example, if we take something like Uber, maybe the customers are paying the drivers directly, and there's just a service which acts as a database that you can go to find the drivers. If you want to go really crazy, Mike Hearn gave a talk last year at the Turing Festival where he's even postulating that maybe the cars themselves are also autonomous programs.
No more spying on journalists?
So another example, if we go back to what we said before, where viruses are today's only self-replicating programs, we can also imagine things like the internet equivalent of an antibody. What would an evolving antivirus program look like? That kind of thing is also possible with this type of platform.
So really, all this boils down to having a broad ecosystem of programs that work for you, programs that act in your interest because you're paying them to do so, and developers who are constantly evolving and improving them. Again, probably some to make money, some to contribute, but ultimately just this very diverse ecosystem that's constantly evolving. And we don't know what the future will look like, but hopefully we're able to give you kind of an idea of what the value web and what Codius can enable.
Yeah, and so we're calling all developers to get involved in this. We're very excited about getting people to try out this new kind of web hosting platform.
And also any cryptocurrency businesses out there. So A lot of us who are into cryptocurrencies, we kind of got into it because we were promised distributed applications, but now there's a lot of services that are centralizing some of these functions back down. So we really think that smart programs and smart contracts can help us add the functionality that we are otherwise lacking to get to the usability that people expect without compromising the distributed nature. So if you're interested in that kind of stuff, definitely check out Codius and see if it helps you for your use case.
And additionally, we're also calling all enterprises and financial institutions who want to add more automaticity to their business processes. So these kind of smart programs can hold money and can help big enterprises or small ones automate different business processes in a trustworthy way.
So get involved, go to codius.org, check out the website. There's a much better website coming, hopefully soon. But in the meantime, there's a mailing list you can sign up to. There's a chat room. We are always available answering questions. So definitely come check it out. There's a white paper if you want to learn more in-depth information about it. And also the source code is available. So if you want to play with it, go give it a shot. All right, thank you. Right.
Anybody have questions?
Right there.
What kind of work do you guys have planned or can you do of kind of getting this perhaps more integrated with Ripple? I mean, I know you guys are kind of your own thing, and I guess maybe you want to be kind of neutral in terms of how to transfer value. But let's say we're doing all these payments, we want to do it through Ripple, right? You guys have any plan on making that simpler or integrating with kind of the gateway D APIs or something like that?
Totally. So Codius came out of certain internal use cases that we needed. So it's things like making Gateway D more secure by having it be distributed. Things like having a wallet that is a little bit more intelligent, like that Wizard of Oz picture. So those are all things that came up from our work on Ripple, right? So we were originally thinking about adding smart contracts functionality straight into the Ripple network, but then came up with this whole idea of having it be separate and just add value to the whole ecosystem, right? Which is a much, much more attractive thing for us. One of our core company values is to be inclusive. So we want to build things that are useful for people in a variety of situations. Also, to answer your question a little bit more, there's some of our enterprise customers have already asked about Codius. So we're trying to develop some of those use cases. And we're also looking into ways to make Ripple as a network more attractive to Codius, but we don't necessarily want to share those yet. So just stay tuned for that.
More questions?
So where are the private keys being held? So in this autonomous Uber example where it takes money, is there a human that's holding the private key that ultimately controls where that virtual currency goes, or is the private key held somewhere on the network where nothing can get to it?
So there's a lot of different ways. Sorry,
repeat the question.
Repeat the question. Where are the private keys held? So in the Uber example, who's actually holding the keys to the money? So there's a lot of Codius is a very flexible platform, so there's a lot of different ways that you could set this up. One way that you can set this up is that each host will provide a unique public-private key pair to the smart program, and so you'd have different public and private keys for each instance of the program that's running. That's one way to set it up. There's a lot of other ways to set it up as well. Most likely, it would be there's a unique public-private key pair for every single instance, and they would use what's called multi-signature or threshold signatures to combine those.
Yeah, so for every use case, like we showed you, you have to think about how much distribution do you need, and then you can use threshold signatures or multi-signatures to kind of get up to that number of hosts that you want to run it on, have something signed, and then boil it back down, submit it to a cryptocurrency network, and then have it be verified.
Yeah. More questions?
What's the connection between Codius and Ripple?
So the question is, what's the connection between Codius and Ripple? And they're two totally independent platforms. It just so happens that we both work at Ripple Labs, but there's no direct connection. It's not baked in at all. One of the things, though, is that in order to make Codius work really nicely, you need something to enable you to pay lots of different hosts who may accept different currencies, which sounds kind of like what Ripple is trying to do. And then for these smart programs to usefully hold money and things like that, you need some sort of value transfer network that is ideally currency agnostic. So that also sounds quite a lot like Ripple. So it's not baked in directly, but there's a lot of ways in which both benefit from the other.
Yeah, and as I mentioned, we need Codius for internal use cases. So for Ripple Labs, it makes sense to develop this technology, and there's no reason not to share it. So.
a week ago, Elon Musk came out with a quote saying, the biggest force to humanity is artificial intelligence. Right? So we're enabling now machines to control us through value transfer. Why?
That's a good question. I think for me, it's like because there's a huge potential for this to be beneficial. And so one of the things that we're already seeing is autonomous programs. Like we mentioned, there's viruses out there, they're replicating, they're getting more sophisticated, probably not intelligent, but definitely more sophisticated. So they should definitely be the honest, the non-malicious counterpart to that, like the legitimate counterpart. And so why not have a platform where legitimate contracts can live as well? So in my opinion, it's up to us to steer that technology and use it for good. Just like any new technology. It doesn't make sense to just put your head in the sand and just hope it doesn't happen.
But it's building controls so that it doesn't go haywire, right? According to 3 rules.
So we actually had this test presentation. When we were practicing this presentation, suddenly the monitor started freaking out. We were like, oh, our contracts are loose. But yeah, this is a good point. So we definitely...
Are you making in SMOP's 3 rules?
It's kind of hard to do that with something like a smart program because they're still written by people, so people can always override those rules, right? So whatever you bake in, people can override it. And also, the platform is just, in a sense, too flexible to have those kinds of rules. But if you have ideas for how to do that, definitely reach out to us and we'll think about it.
I have a question. So this audience, are you thinking to integrate with technologies like Oracle or SAP?
Like what?
Like Oracle or SAP?
So the question is, are we thinking of integrating Codius with technologies like Oracle or SAP?
Partnering with technologies for the package applications?
I think it's not something that we've directly explored, but it's very possible. So as we said, Codius is kind of a general hosting platform, and so we could envision it integrated directly with a lot of different types of services. Kind of the more the better.
Yeah. Right there.
So part of the marketplace now is that credit cards are very ubiquitous. They're accepted everywhere, and they're everywhere. So what do you see as the biggest barriers to entry?
So the question is, right now credit cards are ubiquitous and they're kind of everywhere. What are the biggest barriers to entry for something like Codius? So we wouldn't see Codius as competing with credit cards. There's a lot of reasons why credit cards are really useful. What we do want to enable is, because we work for Ripple Labs, we want to enable things like being able to pay using Ripple, but in the way that you're normally used to. So when I swipe a credit card, that's basically a pull payment because the merchant is pulling money out of my account. With things like Ripple and Bitcoin, that's just not possible today. It has to be a push. I have to fumble around with my cell phone and make the payment. So these are the kinds of things we're looking to enable. There's actually a company that works out of this office called Shift Payments that's making a shout out to
Nakamura right there.
Really cool company that's making a debit card linked to Bitcoin and Ripple. So we're not necessarily interested in getting, there's a reason why this infrastructure is everywhere. It's very useful. I have a credit card in my wallet right now, but we want to do things to make it more secure and also make the cryptocurrency angle more useful.
But still on that point though, you were talking about the security of credit cards, and they are vulnerable because they're ubiquitous, right? But with Codius, if you now have a debit card that's linked to Codius or Ripple or whatever, doesn't it now present a new security risk?
So the question is, one of the reasons why credit cards are so fraught with security issues is because they're ubiquitous. Wouldn't Codius do the same? And I would actually say very much no, because imagine the wallet that we had with the brain. So I swipe my Shift Payments card. They go and ask my wallet for authorization using whatever information they have about the transaction that's trying to be made. My wallet could be as intelligent as I make it, and so the wallet could say, this seems fraudulent, or I've never shopped at this store before. Let me send Evan a text message and wait for his response before authorizing the payment. So you could get a lot more, you could bake a lot more intelligence directly into it.
I think a big point to make as well is that right now some of these algorithms are developed by the credit card companies, and it's very hard for me to have influence on that as a developer, right? So just enabling more people to innovate on that space and innovate on the rules that credit cards use, and also allowing users more configurability in terms of what rules that they want for their particular wallet, just enables more choice and probably better results. Okay, how is Codius different than Ethereum? So Ethereum is essentially on that database tier. So one of the things about Ethereum is that each smart contract or distributed app has to be deterministic. So it cannot, for example, do HTTPS calls. It cannot interact with other servers. It can only interact with the Ethereum ledger. And that requires you as a developer to really rethink how you're writing applications. And it kind of breaks the model of like this three-tier architecture that people are used to. So if I had to compare it, I would say maybe Codius contracts are actually going to use Ethereum as a very powerful programmable database on the back end. But maybe for most of your application logic, you would want to use something like Codius so that you have programming languages that you're used to. You can make outside API calls, and it's just generally easier to develop. That's all about, like, all we're about is like making it very easy for developers to use this platform and not have to learn too many new things.
Sorry, another question. Where do you guys where do you make your money off of the platform? Like, do you take a transaction fee, or how does that work?
The question is, how do we make money off of Codius? First of all, right now, going back to my original point of like, Ripple Labs needs this technology. We're building it anyway. There's no reason not to make it open source. So that's part of it. The other part is Codius hosts are just like any other hosting companies. They can get paid. One thing that might be unique about them is if some Codius host is very trustworthy, they might get paid a little bit of a trust premium. So it could become eventually an interesting business model for us to run Codius hosts and just sort of use the Ripple brand and use the Ripple name as a way to provide hosting in a trustworthy way. But that's definitely not decided right now. It's just an open source project, and we haven't really decided if we want to do that or not.
Okay.
So, sorry, the payments of Codius hosts, that's not baked into the code currently, or the protocol or anything like that?
So the question is, are the payments that Codius does, are they baked into the protocol? Which protocol do you mean, the Ripple or the...
No, like when you were just talking about like paying Codius hosts or something, giving some kind of reward or incentive for people to...
Right, so we mentioned this concept of the value web. So the value web idea is that it's very cheap and easy to transfer value and even exchange value anywhere in the world online. And so Codius kind of at the same time enables that, but also presupposes it. So if you're paying for a Codius host, you kind of have to pay in small increments, or you have to be able to pay automatically. And so some of the technologies that we're trying to use Codius to enable, we also kind of need. So we're trying to move everything forward in like multiple fronts at the same time. The status right now for Codius billing is that it's not fully implemented, and so that's something that we're trying to work on, like again, on multiple fronts at the same time. More
specifically, like in principle, a Codius host could provide any methods of payments that people wanted to do. There's nothing because it's not like we're running all of the Codius platform. It's like we're developing this platform that other people can run, and it's a very similar business model to cloud hosting today.
So if I wanted to make a cryptocurrency application today, I can use any language and any API for whichever cryptocurrency I'm working with, and I can build that application. And the advantage of that is that in that case I can choose to use whichever language I want instead of only JavaScript. What I'm hearing, I guess, with Codius is you have a few things. There's like these things baked in where the source code can be viewable by anyone. I don't know, is that something where you can guarantee that people can trust that's the code that they're seeing or not? But I guess I don't know. Like, it's hard for me to understand why I would be compelled to use Codius rather than just do it.
Right. So the question is, why would you use Codius? You can just upload any program in any language to any server right now. So what is the incentive to use Codius? So one of the reasons that we built Codius is we want to be able to, like if you saw that picture with all the different hosting providers, right now if you wanted to have a truly distributed application, you would have to create accounts at all these different services one at a time, upload your program to all of them, and then connect them together. And so Codius just comes with a bunch of tools to automate that process and make it really easy. So you'd be able to specify and say like, okay, I want these hosts, I want this number of hosts, upload. And it just pays them, it creates relationships with them, uploads the code, and then you're all done. So we actually did a test deployment of Codius the other day, and we spent like 4 hours or something, 5 hours, to set up the Amazon AWS instance.
No, we spent 10 hours,
10 hours.
setting something up on AWS.
Yeah, I might have fallen.
Left the office at 6:45 a.m.
Yeah,
that was how long it took us to set something up on Amazon AWS, and then we uploaded a Codius smart program to it, and it took 5 seconds. So that's the kind of time scale difference we're talking about.
Right. And then the other thing is, again, as you mentioned, you can look at the code, and the idea there is not so much that Codius can somehow prove what code the host is running, but that you only have to trust the host, not the person uploading the code. So right now, if you went to Amazon, you created an instance there, and you uploaded your code, and then you told me, hey, I uploaded this code, I would have to trust you, and I would have to trust Amazon. Whereas with Codius, the host will say, this is the code that's been uploaded, this is the code that we're running, and so I only have to trust that. And in general, like especially with the smart contracts use case, there you have multiple transacting parties, they all have a stake in it, and then you have some hosts which don't have a stake in it. It's much easier to trust those hosts than the other parties that you're transacting with, because those are the exact people that you want to be protected against.
Maybe one more question, if anybody's got. Otherwise, we can call.
All right, thank you very much.
All right, thank you for listening.